7-2 is exploring similar polygons. We talked about what similar means in class today. You saw this. Go ahead and move or look in your notes at this part. Okay, in your test booklet, we already talked about what these things mean, but let's examine them really closely here. Similar means that there are two objects that have the same shape, but a different size. Don't forget, you can hit pause or rewind if I'm going too fast. Same shape and different size. Look at these two pentagons right here. This one's larger, this one's smaller. But yet they have the exact same shape. If I drag this one on top, it would match. A similarity statement is something you need to know how to do by just matching up the parts that go together. I've already marked these, showing that this side goes with this side. Notice I didn't use the congruent marks that we used in the past because they're not exactly congruent. This side is shorter, this side is bigger. So I use matching similarity marks. This symbol goes with this symbol. So AB is congruent to GH. So what you do to make a statement is you just line up the vertices A, B, C, D, E, A, B, C, D, E is similar to, don't use the congruent sign, use the similar sign here, is similar to this polygon. Now just look for the ones that match up. A has one mark and G has one mark. So A goes with G. B has two marks and H has two marks. That means that B and H go together, and so on. G, H, J, K, L. Anytime the directions ask you to make a similarity statement, that's what you do. Use a similarity symbol right there. Two polygons are similar if and only if their corresponding angles are congruent. Remember, that's what keeps the same shape, that their angles are the same. But the measures of their corresponding sides are proportional, not congruent. The angles are congruent to keep the same shape. The sides are proportional to make different sizes. Sometimes in your homework, you're going to be asked to write a similarity proportion. And let me show you how to do that. This proportion is made up of 5 different ratios because there's 1, 2, 3, 4, 5 different sides. So you have to write the ones that go together. What I'm going to do is over here label how I'm keeping things in track. So the top one I'm going to do first is polygon A, B, C, D, E, or the larger one. And on the bottom I'm going to put the smaller one, G, H, J, K, L. And all you do is across the top, list out all 5 sides that you see on this pentagon right here. One side is AB, and that has 1 mark on it. Another side is side BC, that has 5 marks on it. It's going to go with the other one that has 5 marks. Another side is CD. Another side is DE. And another side is EA. Those are all the 5 sides. Notice that it comes from here as well, A, B, B, C, C, D, D, E, E, A. So across the bottom, the important thing here is to make them line up with what matches together. AB has 1 mark, so down here, GH also has 1 mark. That's the one that goes with it. AB and GH are corresponding. They line up together. BC would go with which one? Think about it. It would go with HJ. That has 5 marks, and if you look closely, that one has 5 marks. DC has 1, 2, 3, 4 marks, and down here, KJ has 1, 2, 3, 4 marks, so those are the ones that go together. Likewise, DE has 3 marks, it goes with LK, and lastly, EA has 2 marks, it goes with LG that has 2 marks. So anytime they ask you for a similarity proportion, you have to just show which sides correspond, but you have to make sure that you show all the sides. And the last thing you need to know is called a similarity ratio. We've been studying ratios earlier in the week. It's a comparison, remember. Comparing 2 quantities. In this case, we're going to compare the larger pentagon with the smaller pentagon. So the ratio is comparing the side lengths the ratios of the side lengths. They're not congruent, they form a ratio. So in this particular case, a ratio is not a full proportion, it's just one ratio comparing. So you have to find two numbers that you can work with. Here's one, AB is 18. So I'm going to start with 18 and I'm going to form a ratio out of that. You have to know which number goes with that. 18 is on one mark, so look in here, 10 also has one mark. So those two go together. And ratio should be reduced just like we've been doing in class, divide by 2. And you end up with the similarity ratio of 9 to 2, or sometimes you'll see it written as 9 to 2. That means that the 9 is representing the larger pentagon, and the 2 is representing the smaller one. Okay, you're going to need to use that as we work on the examples. So look down at the bottom. We'll do this one together and we'll finish the rest of them in class tomorrow. Determine. That means yes or no. Determine whether the polygons are similar, and these are the things we need to look at to decide that. If so, write the similarity ratio and a similarity statement. Okay. Test all that the angles are congruent. Remember, we said similar means that they have the same shape and the same size. Same shape, different size. So test that the angles are congruent. That's going to make sure that the shape stays the same shape. And so to test them, we look at what we know. F is 101 and J is 101, so those are congruent. And also we know that G is congruent to K. So F is congruent to J. They're both 101. And also we know that G is congruent to K because that was given. Okay, both of those are given. And the next thing you need to make sure is that the third pair of angles are congruent as well. But you remember a while back we learned that whenever two pairs of angles are the same, then the third pair of angles are the same as well because you automatically just subtract from 180. So angle E is congruent to angle H, and the reason for that would be the third angles theorem. Always give a reason for the type of arguments that you're making here. Okay, test that the sides are proportional. This is a lot easier. All you have to do is set up the number of ratios that you have in the problem. And there's 3 sides, so you have to make 3 ratios. And we're trying to show that the sides will be in the same proportion. The sides will be corresponding there. So the easiest way to set this up is to just look at one of your triangles. I'll start with the smaller triangle, put that one on top. And to keep everything lined up, all you have to do is go smallest to greatest. 10, 12, then 17. If you start with that every time, then it will make a lot of the difficulty go away. Because over here, you don't have to figure out which one goes with which. You just know that the smallest one's going to go with the smallest one. So 15 goes first. And then you go to the middle side. That's 18. And then you go to the larger one, which is 25.5. Okay, we have to see if those all come out to be the same ratio. And I don't have enough space there, so I'm going to do it down here. 10 over 15 and 12 over 18 and 17 over 25.5. I need to see if those all reduce the same. That would mean that they're equal, and that would mean that the proportion works. So we're going to need a calculator. Okay, so this one's pretty easy to reduce. You divide by 5 and you get 2 over 3. This one you can divide by 6. 12 divided by 6 is 2, and 18 divided by 6 is 3. But this one's more difficult, especially because of that decimal. Here's what you do. Move that decimal over so it becomes a whole number, and whatever you do to the bottom, you have to do the same thing to the top. So our new number we're dealing with is 170 over 255. That you're going to have to reduce. You can do that. You can divide by 5, and you can divide and keep going until you get down to the simplified form. But remember, we're trying to see if it equals 2/3. So we can use shortcuts. We can use that hint to help us. Let's see if we can get 170 to reduce down to 2. 170 divided by 2 would be 85. So it's true to say that 170 divided by 85 equals 2. All we have to do is test that on the bottom. 255 divided by 85. 255 divided by 85, and we get 3. So it's true. It works. I know that you don't have those things memorized, but use these other two right here as a clue. And when we've reduced them all, we get 2/3, and that means that all the sides are proportional. So the answer is yes here, and the answer is yes here. If it follows both rules, then your answer is yes. These are two similar triangles. So write a ratio comparing corresponding sides and reduce it. We already did that. Here's one ratio, 10/15. Here's another one, 12/18. Here's another one, 17 to 25.5. But the scale factor, the ratio is going to be 2 to 3. You can write it this way, or you can write it this way. And the last thing you have to do is write a statement with the corresponding parts matching. A similarity statement is what that's called. So all you have to do is find the parts that go together. For the first triangle, it's a triangle, not a pentagon like the other one. For the first triangle, write it in any order, E, F, G. I'll just go alphabetically. Since these are similar, you put a similarity sign, not congruent. And all you have to do is make these letters match up with these. So E has 3 marks, it goes with H, 3 marks. So E is first, so you put H first. The F is 2 marks, so it goes with J, 2 marks. The G is 1 mark, it goes with K, 1 mark, and then you're done.